Hello everyone, in this video we'll be looking at the cross product of vectors. Now the cross product of two vectors, say A and B, which is noted as that and read as A cross B, is given by the product of the magnitudes of the two vectors, the sine of the angle between them, and the unit vector perpendicular to both the vectors. How do we illustrate that? So say we have the vector A there and the vector B there with an angle theta between them. The vector A cross B would actually be that vector there. Notice I said vector because our cross product will give us a vector, not a scalar. So cross product is also known as vector product. Yes, so in simple terms, A cross B is a vector perpendicular to the plane that contains the vector A and the vector B. Realize also that we have a vector on the left hand side and we have a scalar times a unit vector on the right hand side. Remember from what we discussed about unit vectors that a vector is equal to its magnitude times its unit vector. And on the left hand side we have a vector, on the right hand side we have a scalar times a unit vector. And so that should tell us that the magnitude of the cross product is in fact the magnitudes of the individual vectors multiplied together with the sine of the angle between them. And that's an equation that we'll be using a lot as well. Okay, so how do we actually calculate this cross product? So say we have the vector A given by A1i plus A2j plus A3k, and the vector B given by B1i plus B2j plus B3k. What would A cross B be equal to? Okay, so what we do is we calculate the determinant of a 3 by 3 matrix whose first row is ijk, second row will be occupied by the components of A, and the third row by the components of B. The cross product, unlike dot product, is not commutative, so order has to be respected. If it's A cross B, then A comes first, and if it's B cross A, then B would come first. Okay, so how do we calculate this? So we focus on the first row and pick out one element, and when you pick out that element you cross out the row and column that it's contained in and find the determinant of the matrix that remains, which will be A2, A3, B2, B3. When we move on to J, we're now subtracting, so we have a plus for I, a minus for J, and the matrix that remains will be A1, A3, B1, B3 when you cross out the row and column that contain J. And then for K it's a plus again, so this will be plus A1, A2, B1, B2. And then you find the determinant of the 2 by 2, and that would be, in this case, A2, B3 minus A3, B2, product of the major diagonal minus product of the minor diagonal, times I, minus A1, B3 minus A3, B1 times J, and then plus A1, B2 minus A2, B1 times K, and that would be your cross product. Okay, let's look at some applications of the cross product. So we can use the cross product to find the angle between two vectors. Remember from our definition of the cross product, we have that the cross product is given by magnitude of A times magnitude of B times the sine of theta times the unit vector perpendicular to both vectors A and B for the cross product of A and B. We also realize that this means that the magnitude of the cross product of A and B is in fact the magnitude of A times the magnitude of B times the sine of the angle theta between the two vectors. And from this equation you can get that sine theta is in fact the magnitude of the cross product divided by the magnitude of A times the magnitude of B. Notice that the sine of theta is going to be positive in this case because you have positive divided by positive, and so this will in fact be the acute angle between the two vectors. Okay, so say we have the vectors A and B, A being I plus J plus 3k and B being 2I minus 2k, 2I minus 2j plus k, sorry. How would we find the angle between these two vectors? Now you can use the dot product, but in this particular example we want to use the cross product to find the angle. So like we said, we'll have a 3 by 3 matrix. This will be 1, 1, 3. This will be 2, negative 2, 1. And so we'll have this as I times the determinant of 1, 3, negative 2, 1 minus j times the determinant of 1, 3, 2, 1 plus k times the determinant of 1, 1, 2, negative 2. Okay, when you work this out, you'll have 1 minus minus 6, which is 7i. You'll have 1 minus 6, which is minus 5, so this becomes plus 5j, and then negative 2 minus 2, so that gives you minus 4k. Okay, and then we want the magnitude of this. So the magnitude of the cross product is going to be square root of 7 squared plus 5 squared plus minus 4 squared. This gives you a square root of 90. But you know you can write square root of 90 as 3 root 10. Okay, so we go ahead and find the magnitude of A. Magnitude of A is going to be square root of 1 squared plus 1 squared plus 3 squared, which is square root of 11. And then the magnitude of B is going to be the square root of 2 squared plus minus 2 all squared plus 1 squared, which is just 3. And so sine theta is going to be 3 root 10 divided by 3 root 11, which is root 10 out of root 11, or just the square root of 10 over 11. And so you can get theta from the arc sine of that. And this should give you the exact same answer as when you use the dot product. Obviously the dot product is shorter, but the cross product is an alternative in case the dot product isn't familiar to you. Okay, the cross product can also be used to calculate the area of a triangle. Now, familiar with the formula for area of a triangle given as a half AB sine theta, where A and B are two adjacent sides and theta the angle between them. So in terms of vectors though, if we had the vector A as that and the vector B as that, the angle theta between them, notice that the two vectors are emerging from the same point. We could write this as a half times the magnitude of A times the magnitude of B, since the magnitude gives us the length, times the sine of theta. But we know that magnitude of A times magnitude of B times sine theta is in fact the magnitude of the cross product, like we've seen in the equations on the previous slide. And so we can use this formula to find the area of a triangle. Let's work it out with this triangle. So we have the triangle with those vertices. What do we do? So we have to get two vectors emerging from the same point. So we could pick AB and AC. Now AB is going to be given as OB minus OA. We know this from our O level. And this is going to be 5, 5, 5. Position vector is simply got from the coordinates. Minus 2, 3, minus 5. This is going to give us 3, 2, 10 as AB. And then AC similarly will be OC minus OA. OC is negative 2, 1, 2, and OA is 2, 3, minus 5. So it's going to give us minus 4, minus 2, 7 as our AC. Now we want to get the cross product of AB and AC, because we needed to find the area of the triangle. So like we said, this we're going to have IJK in our first row, and then the second row will be the components of AB, which is 3, 2, 10, and then AC in the last row, minus 4, minus 2, 7. When you work this out, you actually get 34i minus 61j plus 2k when you actually work that out. And so the area of the triangle is going to be a half times the magnitude of this cross product, which we just got. So this is going to be a half times the square root of 34 squared plus minus 61 squared plus 2 squared. And that should give you your answer. That's about 34.9321 square units. And you can confirm this using other methods that from maybe coordinate geometry to find the area of a triangle. So that's it for the cross product. Stay tuned to learn more.